Hey everybody, welcome to this quick tutorial on how to perform a one-sample t-test in Excel. I'll walk you through all the steps and I'll tell you right now you don't need any special package for this or any macro. You can just do the entire thing using basic Excel functions. First things first, I have here, as you can see, a data set. So these are just scores between 0 and 100. Just various scores. Say that this is just some test or scores that people have achieved in certain testing. And the first thing that we're going to do is to calculate the basic statistics. We're looking at the mean, the standard deviation, the sample size, degrees of freedom, and your hypothesized mu. So I'll just redo this quickly here, just using Excel. For the mean, of course, average, the same thing. So you can type =, average, open the parentheses, grab your data, and you'll see the 50.6129. Standard deviation, same idea, different function, stdev, open parentheses, grab the data or select the data. I like saying grab the data. 24.86588 n. Now I can kind of look at the data series here and I can see that I have 31 data points, but I'm just going to use a function from basic Excel, count, and just to show you that you can use that as well, just to count how many data points there are in this data set. Now, degrees of freedom, we're going to need that to calculate the p-value. We know well that degrees of freedom simply is your n, your sample size, minus 1. So I'm just doing degrees of freedom, this number here, 31 minus 1. Now, the mu is your hypothesized population mean. So you're trying to test this data set or the sample mean against a hypothesized population mean. So I'm going to pick a number here. I'm going to say 36. So basically I want to test if the sample mean of this data set is different, statistically significant, different than my mu, my hypothesized population mean. Okay, so once we have the basic statistics done, let's have a look at the hypothesis statement. So the first thing we have to do is to state the hypothesis. So the null hypothesis, as you may recall, is the hypothesis that states that there is no difference, there is no change, no variation, as we use in a popular court of law example, is that all are innocent until proven guilty. So the null hypothesis is the status quo, nothing has changed. The alternative hypothesis, the H of A or alternate, is that there is a difference, in this case, between the sample mean and the population mean. So we're trying to test for that. We also have to set up front the confidence level. So I'm going to use the usual 95%, which will give us the alpha risk of 5%. So I'm basically looking at 0.05 as my cutoff for my null hypothesis rejection or acceptance. The t-score will come in handy if you want to calculate your lower and upper confidence interval, and the t-score is basically acquired doing this manually, of course, from the t-test table. I'm looking at the left column here, the degrees of freedom, and then I find 30, and then for the two-tails test, which is the case here, because I'm looking at if the sample mean is actually different than the population mean. I'm not testing if it's greater or less than, I'm testing if it's on either side of the curve, if it's any different at all. So I'm looking at the two tails and then at a 0.05 alpha risk. At the intersection of these two is the 2.042, which is what I'm going to use to calculate my lower and upper confidence interval. So it's manually calculated here, manually as in Excel, and you can see the formula there. I'm basically saying my mean minus my G7 in this case here, t-score, times your standard deviation over the square root of n. So that's a formula for the confidence interval. You will see that for the lower I'm using minus, and then for the upper I'm using the plus sign. So the minus here, and then the plus sign here. Okay, so back to the hypothesis testing here. What I'm trying to find now is my t-statistic. I have the formula down here. So to calculate the t-statistic, we're going to have to use your sample mean minus your mu or hypothesized population mean divided by standard deviation over the square root of n. So that's just a formula for the t-statistic. And then I showed down here the actual numbers that we have. So you can see that my sample mean is 50.6129 minus my hypothesized mu, 36, divided by my standard deviation over the square root of 31. So that's exactly the calculation that I'm performing right here in this cell. I just wanted to show you how I actually perform this calculation here, say by hand, just to show where the numbers fit in. If you do this by hand on your calculator, you'll find exactly 3.272, which is what I have here. Okay, so after that, what we need to do next, and I'm going to delete it here to show you how it's done, it's to calculate the p-value. So the t-statistic is just telling me how far from in the t-distribution, as with the normal distribution, your mean would be 0, and then you have, in this case, 2.042 standard deviations on each side of the curve. It's basically telling me that it's far out. I can tell that it's far out already. I can tell that this is sitting well past the 2.042, but I wanted to find the p-value and be exact on that number to perform my test. So if you simply go to there's a function Excel, the t-dist for t-distribution, and you want to use the 2t, which is the 2-tail. Double click there or hit tab on the keyboard. It's going to ask you for x, which is the t-statistic in this case that I have here, comma, and then the degrees of freedom. So that's why I needed to calculate that ahead of time. If I do that, I will find my p-value 0.0269, which is essentially 0.3%. Now, recall that in this case we set the alpha risk for 0.05, so anything lower than that we will reject the no. As a good friend of mine used to say all the time, if the p is low, the whole must go. P is low meaning lower than your alpha risk. And if it's greater, we fail to reject the no. A lot of statisticians and other people in the field don't like saying accepting the no. They would rather say fail to reject the no. So this is our result, 0.00269. It is definitely less than the 0.05 set by my alpha risk. And in this case, we will reject the no in favor of the alternative. So recall that the alternative states that there is a difference, a statistically significant difference between the sample mean and the population mean. And that's what we're testing here. So we can say that for this example, this data set and this sample mean, it is statistically significant, meaning statistically different from the hypothesized population mean of 36. So this is it. I hope you've learned something here, and I hope to see you again.